The lesson outcome for this video is, I can graph a linear equation using a table. Okay, so what we have right here is we have an equation using x and y, and if we find some points that are true for this equation, if we use an input for x, as we've been talking about in class, if we put an input in, and then we do some math and calculate the output, that will create a point, okay, and then that point can be plotted on this graph or coordinate plane. So we're just going to start with one right off the bat, and this table is going to help us stay organized when we try to find our points. So we are going to put in an x value. Again, that's our inputs, right? We know all about inputs. And then we're going to do some work in here. We're going to write the equation with the input and evaluate it here. And we're going to find the y value, which is going to create a point for us, an xy coordinate pair with an input that provided us with the output. All right, so we are going to take this equation right here, and I'm going to write it in here with this number put in for x as an input, right? So we have y equals 3, and the input is -1 plus 2. All right, so again, all I did is I rewrote this equation right here. The only change I made is instead of an x, I put in the -1. And we've been doing that with function work as well. So y equals -3 times 1, which is -3 plus 2. And then we know that -3 plus 2 is -1, so the -1 goes here. Now remember, when we put an input in of -1, it does not mean that we will always get an output of -1. It just happened in this case. So input of -1 provided us with an output of -1, which means that is our point. And now we can go ahead and we can put that point on our coordinate plane. So, practicing our plotting points from the origin, we're going to move 1 to the left on the x-axis, so to -1, and then 1 down on our y-axis, -1 right here. So -1, -1 will be this point right here. So we plot that point. Now we're going to go ahead and do the same exact thing for our other 3 inputs, 0, 1, and 2. All right, so y equals 3 times 0 plus 2. Y equals, what's 3 times 0? Well, it's 0 plus 2, and 0 plus 2 is 2. So when we put an input of 0, we got an output of 2. So that coordinate pair is on the coordinate plane. So 0 on the x-axis and then 2 on the y-axis will give us this point right here. The next one, y equals 3 times our x value, our input, which is 1 this time, plus 2. Y equals 3 times 1, which is 3, plus 2. And 3 plus 2 is 5. So our point is, an input of 1 provides us with an output of 5. So our point is 1, 5. 1 on the x-axis, 5 on the y, will give us this point right there. One last equation, or input I should say, y equals 3 times the input of 2 plus 2. Well, 3 times 2 is 6, and 6 plus 2 is 8. An input of 2 gets us an output of 8, so the point 2, 8 is on this function or equation. So 2, 8 is right here, and if you see, if you've done this math correctly right here, you will always find that all of your points line up to create a line, because this is a linear equation. And a linear equation means it is the equation of a line. So we can draw the line through these 4 points as best as we can. Sometimes it's hard on an iPad. Pretty good. And we're going to put arrows on the ends because we know that the points that are on this line right here extend infinitely forever. If I were to add another set of input-output values here, I could pick the number 73 and put that in and find its output and then find that point, and that is going to be somewhere, well, way over here. If you keep going further and further this way till you get to 73, and then you're going to have to go way, way high up on the y-axis, you're still going to find a point that's somewhere way up there that lands on this line. So that's our first example of graphing a linear equation using a table. Okay, so we're going to do one more example here, and it's important to do this other example because, first of all, I'm going to throw some negatives in here to mess with your integer work a little bit, so be careful there. But also you probably will notice that instead of a y equals equation, we have an f of x equals equation. Now I want to remind you that f of x does mean the same as y. It is our function when we have a certain given x value, it gives us the y value when we put that x value in here. So we've worked with function notation, and it's just the same type of thing that we're going to be doing right here to find when I have an input of x to find the output, which we will call again f of x, which is another name for y. So nothing really different there, just notice the notation. Alright, so we're going to start with f of, notice, we're going to start with f of -1. So f of -1, I'm going to put -1 in there, and then I'm going to put -1 in anywhere else that I see an x. So I hope you see that this is not different than the previous example. The only thing I've done a little differently is instead of y equals right here, I have f of -1 still inputting our x value here. So f of -1 equals equals -4 times -1, and -4 times -1, well, a negative times a negative is positive, so this will be +4 plus 2. So when we have, so 4 plus 2 is 6. So when we have our input of -1, our output, or f of -1, is 6. So we're going to plot -1, 6. -1, 6 is going to be right here. All right, let's try another one. So f of 0 equals -4 times 0 plus 2. And 0 is such a nice number to work with, right? Because -4 times 0, well, that is 0. Anything times 0 is 0. So 0 plus 2, and 0 plus 2 is 2. So when x is 0, f of 0 is 2 for our output. Be careful with 0, 2. Okay, where are you picturing 0, 2 over here? I hope you're not picturing it right there, because that is 2, 0. 0, 2 is right here. 0 on the x-axis, 2 on the y-axis. All right, f of 1 is going to be -4 times 1 plus 2. So f of 1 equals -4 times 1, well, that's -4, plus 2, and -4 plus 2 is -2. With an input of 1, we get an output, or f of 1, which is -2. So 1 comma -2 is plotted right here. And notice so far your 3 points are in a good line here. And so let's double check with our last point. F of 2 for an input equals -4 times 2 plus 2. Following the order of operations, when we simplify, f of 2 is -4 times 2, which is -8 plus 2. -8 plus 2, well, that's -6. And therefore we have a point 2 comma -6. And we will make sure that 2, -6 is right in line, and it is. Again, don't just draw your line like through these 4 points and stop like that, okay? That's just a part of this function, okay? It's just the part of the function that we use these specific points to help us find, but really that line will go infinitely both directions. All right, that's all for now.